Okay, I would have to multiply this by y to over 1/6 and y to the 1/6, right? Wouldn't that give me 6/6 on the bottom? Because I'm going to add the fractions. So then on the top I have y to the 1/6. On the bottom I have y to the 6/6. What's y to the 6/6 power?
1.
1. So I got rid of my radical. This right here is the same as that. Okay, just a different way of writing it. I think this stuff is really interesting. I don't know who came up with it, but I think it's kind of a cool math. Different. All right, let's keep going. What if I have the 8th root of 16 over the 6th root of 2? Can I do that problem? This is an 8th root, this is a 6th root. Am I allowed to divide something that's an 8th root and a 6th root together? No, can't do it. Okay, I can't take the 8th root of 16. I can't take the 6th root of 2. So it looks like I'm stuck. Anytime it looks like I'm stuck, I'm going to switch it over to fractions. So how can I write that 16th as a fraction exponent?
16 to the 1/8 power.
Okay, 16 to the 1/8 power. How can I write the bottom as a exponent with a fraction in it?
2 to the 1/6 power.
2 to the 1/6. Okay, you're going, that didn't help me. Okay, didn't help me at all. If I can make these have the same base numbers, then it's going to help me. Because then if the base numbers are the same, what do you do with the exponents? Do you remember that?
Subtract them.
You subtract them. Okay, so is there any way, obviously I can't do anything to the 2. I can't make that any smaller. But can I take the 16 and make it have a base number of 2?
Divide it.
Do I? Not divide it. 16 is equal to 2 to the what power?
Fourth.
Fourth power. Okay, so I can rewrite this top one as 2 to the 4th power raised to the 1/8 power. Okay? Thunder. Maybe? Okay, so I have 2 to the 1/6 on the bottom. Okay, what do I have on the top? Four times 1/8 is 4/8. 4/8 reduced down as what? 1/2. Okay, so I have 2 to the 1/2 power and 2 to the 1/6 power. Okay, now you just told me if the base number is the same, what am I going to do with my exponents?
Subtract.
I'm going to subtract them. So what I want to do here is 1/2 minus 1/6, right? Common denominator. How can I write 1/2 with a base number of 6? 3/6. Okay, so I'm going to change that to 3/6. When I do those out, I get 2 to the 2/6 power. What's 2/6 power? 1/3. Cube root of 2. That's what that's equal to. I just think that's cool. I mean, all of a sudden something that we thought we couldn't do, now we can do by changing them to fraction exponents. All right, let's do it. I don't know. Maybe I just think weird. Okay, but I think it's cool. You're probably going, you don't get out much. All right, look at this. See what you can do with this. Go ahead and try this problem. Okay? You know that you're going to write them as exponents, and then you're going to try and make the base numbers the same. So that's the direction you're going to go in. Okay, you can't break down the 32 into 4, okay? So then you begin to go, can I break them both down into something else? Well, they can both be broken down into 2. 32 is 2 to the 5th, 4 is 2 to the 8th. I multiply those, which gives me 2 to the 1/2, and this gives me 2 to the 1/4. Common denominator here, and then I just subtract. So technically what I have is the 4th root of 2. Yes, no, maybe? Does that make sense? Okay. What if they gave you something like this? And they say, simplify. And you go, there's nothing I can do. Okay, and we want to go, oh, it is simplified. Well, we need to go ahead and go, let's write it as a fraction. Okay, so I turn around and write it as a fraction, and I go, okay, that's the same thing as 2 squared times n squared to the 1/4 power. What do you do to a power raised to a power? Multiply it, right? So this becomes 2 to the 2/4 power, or 2 to the 1/2 power, and this becomes n to the 2/4 power, or n to the 1/2 power. You know how I simplify that? I get the square root of 2n. Can't get there from there. But if you go through with the exponents, you can reduce it. Is that, when in doubt, switch it out. Okay, switch it to just the opposite of what you have. If you have roots, switch it to exponents. If you have exponents and you're stuck and don't know what to do, switch it to roots and see if you can see it. Okay? All right, one more thing. Let's say you've got this. Can I leave that like that? What does that mean?
Square.
Square root. Oh wait, I got a square root in the bottom. Remember we learned that that's breaking math law. So I have to do something to get rid of it. Now, if you're stuck here and you go, I don't remember how to do this problem, go ahead and switch it to roots. That's actually, the +1 is down here. Okay, that looks confusing. Switch it to that. Now what am I going to multiply to get rid of it?
Square root of 8.
Keep going.
+1.
+1. Okay, the conjugate, remember? Now, if I want to on the top, I can just write this. Square root of a plus 1 squared. Right? Because I got 2 of them. On the bottom, I've got first and last, so I've got square root of a times square root of a is the square root of a squared, which is a, right? Minus 1. Okay? That gets rid of it off the bottom. Would you agree? All right, so when in doubt, you can convert it. But let's do it without converting it. What do you think I would multiply that by? What's the conjugate of that?
Anything a 2 plus 1.
It's actually a to the 1/2 plus 1. Okay, just exactly like it stands. Okay, a to the 1/2 plus 1. Again, the chop is being multiplied by itself. So I can just go a to the 1/2 plus 1 squared and let it stand just like that. On the bottom, a to the 1/2 times a to the 1/2. What is that? A to the 1/2 times a to the 1/2. What do I do? If the base numbers are the same, what do I do with the exponents?
Add.
I add them, okay? What's 1/2 plus 1/2?
2/2.
Which is
1.
just a, okay? Which means, I did that one wrong. I don't know how I got the 1/2 on there. Okay, because that when we did it out, we did a, the square root of a minus 1 times the square root of a plus 1. I must have just accidentally put that on there. Okay, oh no, I erased that part, didn't I? Okay, So when I multiply here, I get A. When I multiply here, what do I get? Okay? I think that way is easier. But that's just my personal opinion on it. Okay, let's do this one. Let's do it with the exponents. What would I multiply that by?
B to the 1/2, like A to the 1/2.
B to the 1/2 minus A to the 1/2, because it's the conjugate of it. Okay, on the top, B to the 1/2 minus A to the 1/2. Okay, I have to do distributive property on the top. So I have A, B to the 1/2. But what happens when I multiply A times A to the 1/2? What do I do? Base number's the same. What do I do with the exponents? Add them. Okay, this is the same thing as saying 2 over 2, is it not? Okay, so that is 3 over 2. Okay, if I want to break that down, I could just leave it like that. I could leave it as A times A to the 1/2, because that's actually a root that I can then take another root of. Okay, so if I wanted to, I could just do it like this. And that would be fine to leave it like that, or you can combine it. All right, on the bottom, I'm multiplying that times that. What do I get? B to the 1/2 times B to the 1/2.
B.
Just B. A to the 1/2 minus A to the 1, or times a negative A to the 1/2. Just A. Okay, and I can leave it just like that. If I had written this out, it would have been the square root of B plus the square root of A. What would you have multiplied it by? Right? Isn't that what you would have multiplied it by? Okay, so then I turn around and go, okay, distributive property on the top is A times the square root of B minus A on the square root of A. That's exactly what I have. Okay? On the bottom, square root of B times the square root of B, B. Square root of A times the square root of A, A. Same thing, I got it there. Okay, if you get stuck, change it. Okay? All right, I am going to give you your homework on this. It is page 300 and 301. And I want you to do 24 through 58 even. Okay? And you got about 15 minutes.